Okay, assuming you saw the last video, it turns out I found the mistake, and it was sort of uber classic. When I squared this, I didn't square the denominator. 3 times 3 is 9, last time I checked. And so when you factor that out, the square root of 9 is 3, and it would have canceled with this 3, and there's no 3. And then you carry on about your business, and you wind up without, ultimately what happens is you wind up without this. And there's your classic equation of a circle. Radius 3, and it's centered x coordinate 1 and y coordinate 2. So, hey, silly mistake. What are you going to do? Now, moving on, let's do question. Again, I don't know how to refer to these, but it's because I ridiculously made question 1 question 0. But moving on, as it's printed on the sheet, this is question 3. Let me erase all this. Question 3, which is the 4th question of the exam. And it's got 2 parts. And I'll just do the first part because they're both the same. And the question asks us to find the slope of a tangent line. Well, that's just the good old Calc 1 stuff, except now we're using a parametric equation, and we can use our theorem, which makes it pretty darn easy to do this. The theorem that we discussed, I think, in the doing the last question, or maybe the question before that. Okay, sorry. Board. Oh, for crying out loud. Board management here. There we go. All right, so let's see. The question reads, hopefully you have it in front of you, but find the slope of the tangent line at the given value of the parameter. So here, we'll do the first one. We're given that x is equal to 3 sine of t. Hey, it looks like the last question. And y, 3 cosine of t. Is that the same? That's almost what the last question was, not quite. Y is equal to 3 cosine of t. And we are told to find the slope of the tangent line when t is pi over 4. So we're interested in this when t is pi over 4. Maybe I put a little sub-zero there like that. And so what we want to do is just find dy dx. And according to the theorem in our book, this is y prime, or y, you have to take the derivative of y with respect to t divided by x prime. Here, I'll put a t in there like that. And that should be a straightforward matter, I suppose, because look at the function. So what's the derivative of this with respect to t would be negative 3 sine of t, and the derivative of this with respect to t would be 3 cosine of t, and the 3's nicely cancel each other out. And if you want, sine over cosine is tangent, so that's a negative tangent of t. And we're talking about the point pi over 4. So what we're interested in here is, I could do this, like say, evaluated when t sub 0 equals pi over 4, and I could carry all the way down. And then what we would get here is negative tangent of pi over 4, which we all know is 1, and so negative 1. So not too bad. Pretty straightforward question. And you do the second one the same way. Okay, now we get to more difficult, or at least more difficult sounding questions. So the next question is question 5, as you read it on here. Question number 5. Oh, no, sorry. Oops. Question 4, which is the 5th question. Find the second derivative of y with respect to x. So here we have to find a second derivative. And as you may recall, or may remember, or look it up, or whatever, it's not quite as easy. So let me write down the first function here. We have x equals t to the 4th, x equals t to the 4th, and let's see, y equals, what does y equal? T minus t squared. T minus t squared. Now, again, one thing we could do is we could try to solve either one of these for t and substitute in the other, and then we could use our Calc 1 skills, right? At the same time, let me call it the page number on this. Oh, this is the book that it's pretty tough to call it the page numbers on. Well, this is in section 1.2. And let me get the theorem number here to call your attention to it. Sorry, just 1 second and I will find this. Second order derivatives. Well, it doesn't really have this boxed in, but it's listed if you look at 1.2. And we're also in section 1.2. Maybe that's kind of awkward here, but we're in section 1.2. And there's a box labeling the equation for the second derivative. And I'm looking at the various forms here and trying to see which one might be the best for us to do. Here, let me write them down just to refresh our memory. D squared y over dx squared. So remember what that means is the second derivative. You take the derivative of y with respect to x, and then whatever you get, you take the derivative of that with respect to x. And what we have here is that we can write this down, and I always take a close look at this. I'm not sure why, but I'm very dubious as to my memory here. We have this of dy dx. And all this is divided by dx dt. And that's a lot of stuff. But what we should probably do is just go through and determine each little piece of the puzzle, and then put it all together. Dy dx was the sort of thing we just did in the last problem. So let's maybe figure that out first. So dy dx, we have that theorem that says we can take the derivative of y with respect to t, so 1 minus 2t, divided by the derivative of x with respect to t, so that's 4t cubed. You have to make these decisions, right? I mean, do you want to try to simplify this? Do you want to leave it as it is? Here, look, the first thing that occurs to me is maybe it might be easier if we wrote it like this. Look, you could split this up. 1 over, here, I don't know how much detail you want me to show, but 1/4 t to the negative 3 minus, what would you have? Well, here, maybe I'll show some of the details, right? 2t over 4t cubed. And that would equal 1/4 t to the negative 3. We do get some canceling here, right? So minus 1/2 times what? T to the negative 2. Now, the reason I might do this is think this will be easier to take a derivative of this, and that's what this formula says we should do. Now we're supposed to take the derivative of this with respect to t, and that should be pretty easy to do. So d dt, the derivative with respect to t of all this business here, 1/4 t to the negative 3rd minus 1/2 t to the negative 2, and that's equal to, all the good old derivative rules, right? So bring the negative 3 down in front, negative 3/4 t to the negative 4. Let's subtract 1, right? And then plus, we'll bring the negative 2 down in front, t to the negative 3. So that's what's going to go up in this numerator. And we're also going to need dx dt, the derivative of x with respect to t. So we can do that pretty quickly. I think I already did, actually. Dx dt is 4t cubed. So let's put it all together. So this is equal to negative 3/4 t to the negative 4 plus t to the negative 3, all divided by 4t cubed. And I think somebody on the exam asked me, do we have to simplify this? And the answer is, of course, no, you don't, but you really should try. Yes, that is the answer. Ta-da, full credit. Nonetheless, let's give it a go and see what we get in terms of simplifying it. Let's split up this fraction. This first part here, we'd have negative 3/4 times 1/4 times t to the negative 4 over t cubed, and then plus, from this part right here, t to the negative 3 divided by 4t cubed. And now, how much is this going to simplify? I don't know till I do it, but let's give it a try. Right here, we have negative 3 over 16 times altogether here, t to the negative 7th. Nothing particularly nice about that. Nonetheless, let's see, plus 1/4 times t to the negative 6th. I don't know. You could leave it like that. We could try rewriting it. I don't really know what the advantages and disadvantages are. Just for fun, we could maybe try writing this like this: -3 over 16t to the seventh plus 1 over 4t to the power of 6. Get a common denominator of 16t to the seventh, and we'd have -3 plus, we have to multiply this top and bottom by 4t. So 4t all over 16t to the seventh. Which is simpler, this or this or this? And I don't know, none of them particularly great. I guess I would probably go with that one, but it depends on what we're going to do. I mean, that's a derivative. If we were going to set it equal to 0 and do a second derivative test, something along those lines, then this would be preferable, because the only way that could equal 0 is if the numerator equals 0, and I wouldn't have to worry about that. But I didn't say that on the exam, so if you left it in its original, rather icky looking form there, that's fine. So that my video doesn't get destroyed by my computer, I'm going to end this one, and we'll continue on with the next video.